Okay, today we're going to look at section 5.1, polynomial operations. This is where we're going to learn to add, subtract, multiply, and divide polynomials. So what is a polynomial? Let's start there. So here is the things we need to know about a polynomial. Polynomials are of this type right here. And just so you get an idea, these two terms at the back end of the polynomial is your linear, your line. This is your mx plus b kind of a thing. But polynomials can go up to as high of an exponent that you want. So generically, we talk about the highest exponent here and all the way down to an exponent of 0. These a's usually throw people off, but just remember from our sequence format that these little sub numbers just mean position. So here is a number, which is a coefficient of this term, and it's a sub n because it is the coefficient on the x term that has an n in the exponent. So if this was a 5, then this would be a 5, so that you know that they go together. They're part of this one term. That's the only purpose of the counters down underneath, the subscript numbers. It just tells you what position it's in. Starting from the back, this is the 0 position, then the 1 position, the 2 position, all the way up into the highest position possible. So these are called coefficients. They're real numbers. And then if you look at the x's, each term has an x in it, except for the last one here. And these are the exponents on x. And they start at the highest, and they decrease by 1 each and every time, all the way down to the lowest one that's there, which would be x to the 0. This is why you don't see an x in this term. X to the 0 power is 1, so they don't put the x term here. This is x to the 1, even though we don't put the 1, but it's still x to the 1. This is the proper standard form for a polynomial. It's from the highest exponent all the way down in decreasing order down to the constant. A sub n is the leading coefficient. Even if these terms were all mixed up, the leading coefficient, I'll put this in here, the leading coefficient is the coefficient of the term with the highest exponent. So no matter where it is in the terms here, if this is all jumbled up, the leading coefficient is always the number in front of the x with the highest exponent. So that's the leading coefficient, not the what, because it's first. Although if you write it in standard form, it will be first. So if it's not in standard form, it can be the leading coefficient just follows the highest exponented term. The constant is always the last term if it's in standard form. It is the term without a variable because it's x to the 0, which is 1. And we categorize all polynomials based off of the highest exponent. In this case, that is n, and we call that the degree of the polynomial. And so we classify all polynomials based off of their degree. We call degree 2 would be quadratics, degree 1 would be linear, and then after that, degree 3 would be cubics, and degree 4 we just call degree 4. They got other names too, but we just use degree 4, degree 5, degree 6, and so all the ones that have those highest degrees are all categorized into a single group by the degree. So this is the standard form of a polynomial. We're going to add, subtract, and multiply these polynomials in this lesson. So how do I add and subtract? What is my process I'm going to follow? When you add or subtract, each polynomial that you are either adding or subtracting should be put in parentheses with either the plus or the minus sign between them, so that whether you're adding or subtracting accordingly. If you are just adding, then the parentheses aren't serving any purpose, okay? Unless there's a number in front of the parentheses, and we'll talk about that at a later date. But just two polynomials that you're adding or subtracting. If I'm adding, remember order of operations, when we solve things, if there's parentheses, we need to get rid of them. So we want to drop the parentheses because they're not doing anything. And then simply combine like terms. And I think I have, so what are like terms? Like terms are terms that have the exact same variable. It cannot be different in any fashion. It doesn't refer to the same, having the same letter. It means exactly the same variable. For example, 2x, negative 5x would be considered like terms because they both have the same variable, which is called x. But this one, 2x and negative 5x squared, are not like terms because even though they both have an x, this is an x to the 1, this is an x squared. Those are not exactly the same, so these are not like terms. You cannot combine those. You can't combine things like, you can only combine them if they have the exact same variable. Okay, so that's what like terms are. So if I'm doing adding, that's what I would do. How do I subtract? When I subtract, what you're going to notice is there's going to be a minus sign in front of the second parenthesis. Okay? And so then I have to subtract every term of the second parenthesis. So we distribute the negative sign throughout the second parenthesis to drop the parentheses. And let me show you how this is done. I'll do an example for you. So here's a polynomial, 5x squared minus 2x plus 1, and plus 3x squared plus x minus 4 minus x squared plus x minus 3. So I have this sum and subtraction right here of these polynomials. And so what I have to get rid of the parentheses. So I look here at this one, there's nothing in front of these parentheses, so these parentheses can be just dropped. If there was a number in front, I would have to distribute. If there was a minus sign in front, I would have to distribute. If there's nothing, so I can just drop the parentheses. There's nothing in front of this one. I mean, there's a 1 technically, but we don't worry about the 1 part. So I can drop those parentheses, so you just write everything as you see it. But this one has a minus sign. So I'm not just subtracting the first term, I'm subtracting all of those terms. So what I need to do is I need to get rid of parentheses, so I need to distribute. This is like a negative 1 in front. So you're multiplying a negative 1 to each term that's in there. So a negative 1 times x squared would be minus x squared. A negative 1 times x would be minus x. And a negative 1 times negative 3 would be positive 3. So the negative just basically changes all of the signs of the polynomial terms to its opposite. So plus, plus, minus became minus, minus, plus. Once I have eliminated all parentheses, then I can combine like terms. You want your answer to be in standard form for polynomials, which means the highest exponent first. So ignore everything else and just look at the x squareds. I got 5x squared plus 3x squared minus 1x squared. So that is 8 minus 1 is 7. So I have 7x squareds. Some people will go through and just cross those out so they don't look at them again once they've combined them. And you can do the same or not. It depends on your preference. The next one after x squared is x. I have a minus 2x plus x minus x. So looking at these three terms to be combined up, we can see that those are opposites, so they will become 0. And I'm left with just the minus 2x. And so those are taken care of. And then I do the constants. So I have a 1 minus 4 plus 3. So as we can see from that, they're also going to drop out because 1 plus 3 is 4, minus 4 is 0. So there is no plus nothing. You don't need to put plus 0. And that is your solution right there. You have combined like terms, you've added and subtracted polynomials, and simplified it to its final form. That is how you add and subtract. So let's talk about multiplication. In multiplication is just an extension of the distributive property. Like when we distributed the negative sign throughout, that's what we did here. We distributed, multiplied to each term inside the parentheses. So multiplying is just an extension of that distributive property. Illustrating it again right here. A times B plus A times C. And what you're going to do for multiplying is you're going to multiply each term of the first polynomial to each term of the second polynomial. That's what you're going to be doing. You're going to multiply numbers to numbers, and then you're going to use the product rule of exponents for the variables. Meaning, I'm going to multiply things together, so I would add the exponents. When I've done all that, then I can combine like terms and put it in descending order, which is the proper form for polynomials. So let's do some. We're going to follow that process. So here's a couple of examples I'm going to lay out for you. Here's one where I just have a single term. And when you multiply, you want each polynomial to be in a parenthesis if it's more than one term. So I don't need this in parentheses because it's only a single term. This is called a monomial because it's one term. So monomial means one term. A binomial is a polynomial that has two terms. A trinomial is three terms. We don't do any things beyond those three right there. After that, we just go to polynomial. We just say four-term polynomial or five-term polynomial, something like that. So these are the special named ones and what they mean. What does polynomial mean? Should have told you that one earlier. What is a polynomial? Well, it's from the Greek. The poly means many, and the nomial means terms. So polynomial means many terms. Okay? So how am I going to multiply this? Well, I'm just going to do the distributive property. This times that. So we go number to number. The number here is a 1. 6 times 1 is 6. And then we do exponent rules, x squared times x squared, and we add the exponents. So 2 plus 2 is 4. So that's how that multiplies together. Do the next one. Then I draw the little line so I don't forget where I'm at. So I got this times that, number to number. So 6 times a negative 4. 6 times a negative 4 is negative 24. X to the second times x to the 1. Add the exponents, you get x to the 3. Do the last multiplication over here. Number to number, so 6 times a negative 3 is a negative 18. And then x times, there is no x term, so the x squared just comes down by itself. Just continues on. It'd be like a 1 over there. And so there you go. That would be your multiplication of those two polynomials. So let's look at another example. So this time I'm going to multiply two binomials together. Now, same thing. Each term of the first polynomial must multiply to each term of the second polynomial. So take your time, do one at a time. So I draw the line so I don't forget the ones I've done. That times that, so 3 times 3 is 9. X times x is x squared. Now, this one multiplied to here, so I'm also going to multiply to the back one. So 3 times 2 is 6, and then the x. So this 3x is now multiplied to both of those terms. So now I'm going to move to the minus 4 and multiply to those terms. Negative 12x, and then negative 4 times 2 is negative 8. So I've completed the multiplication. Now there's no more parentheses. Looking at these terms, can I find anything that can be combined together? Are there any like terms? Well, there is no other x squared, so this one is done. But I have these two x terms, so I can combine those together as 6 minus 12, which is a negative 6x. And there's no other constant with that one, so it just comes down as your final answer, and there you go. Well, what if I have more than two terms in two terms? Does it change what I'm doing? X squared plus 3x times, and then this one here we'll do 3x squared minus 2x plus 4. Well, now I'm multiplying a binomial to a trinomial, and the process is exactly the same. Just take your time. One at a time. So that times that gives me 3x to the fourth. Remember, adding the exponents. X squared times that is minus 2x to the third. And then x squared times that is plus 4x squared. So the first term has then multiplied to all three of those. And then I'm going to multiply the second one to all of those. That's 9x to the third minus 6x squared plus 12x. Now I'm going to look and see if there's anything that can be combined. Starting with the highest exponent, is there any other x to the fourth here that I can combine to? The answer is no. So then that just comes down as the first term. After x to the fourth, I look at x to the thirds. And you can cross off as you go if you want. So here's an x to the third, here's an x to the third. So a negative 2 plus 9 is a plus 7, x to the thirds. X squared is next. 4x squared minus 6x squared is a negative 2x squared. So those are gone. And then this is the only x term, so it just comes down. And there you go. Now, here are some special things that happen that you need to be aware of so you know how to handle them when they do occur. What does this mean? So this is a binomial, and they put a squared up here. So, and I asked you to multiply this out. What do I have to do? Well, you have to do what this means. A number squared means it is, and you want to rewrite it. So this means x minus 4y times x minus 4y. You need to rewrite this. You want to rewrite without the squared. Once you have rewritten it, then you can multiply this out. It makes it much easier to do. So then this becomes x times x. And then we have x times a negative 4y. Okay, well, they're different letters, so I can't add exponents, right? The exponent rule is only when they're the same letter. These are different letters, so they just come together. And when we write them together, you want to put them letters in alphabetical order. So x times a negative 4y becomes minus 4, and then it's x times y, and you just write it in alphabetical order xy. Don't write yx because the proper format is to put all letters in alphabetical order. So there's that term. Then we move to this one. You see, you get the same thing again. Even though it's 4y times x, I'm going to write it as 4 times x times y, alphabetical order. And then negative 4 times negative 4 is positive 16. Y times y is a y squared. Okay? So, more than one variable. Then write in, alphabetical order. That's what we said right here. Okay? Combine like terms, you can see right here, these two are like terms because they have the exact same variable. They both have an xy. Okay? Because they both have the variable xy, then they can be combined. There is no other variable that's in here in any term that has a y squared, so nothing will combine to that one. Nothing will combine to this one because this is the only x squared in here, but these two have the variable xy, so they can combine together. Negative 4 and negative 4 is negative 8 xy's. And that would be your final answer right there. So that's how you add, subtract, and multiply polynomials.